Let's get it started. Welcome, everyone. Thank you so much for joining today's webinar. Today, we're going to have the smart processing mine as part of our mining innovation across the life cycle series. I am Clarissa Campos. I'm the New South Wales membership manager, and I'll be your host today. I would like also to acknowledge the traditional custodians of the land in which we meet today. I am from the Wabago people, but I would like to pay my respects for all the Aboriginal and Torres Straits Islands all across the country in order to get this webinar going. I would like to really thank you, thank the sponsors and the participating companies today. So we have Glencore Technology, Endress+Hauser, Jord and Bray Controls presenting on the topic. And just a bit of, some instructions if it is your first webinar with us. So we will have each company presenting on their topic. Then we will have Q&A towards the end of the webinar. So if you have any questions toward the sessions, please send them through the chat box through Zoom. If your question is, targeted to any of the speakers, please write their name down so that we know which one you'd like to answer your concerns. But let's get it started. And today's webinar will be all about the processing mine. This is a very significant topic for the industry nowadays. There are significant transformations going on in the mining sector, driven by automation, digital solutions, AI, and sustainability. And the mining innovation across the life cycle will dive into the smart processing technologies, what's happening in that world, and what are the latest innovations that you can access from our experts today. I would like to get started with Glenn from Glencore Technology. So Glenn is the Director of Growth and Solutions at Glencore Technology. In his presentation, he will be exploring how the Jameson cells and ISOMIL can offer an alternative approach to traditional self-flotation and grinding technologies. It is an application across a wide range of commodities, and those proven solutions provide a great return on investments and operations using less power with a lower carbon footprint. He will also provide an overview of those innovative approaches to mineral processing and how many mines across Australia and the world can benefit from those new technologies. Over to you, Glenn.
Great. Thanks, Clarissa. So today's discussion is really around some of the learnings that we've had and what we believe the industry needs to adapt to face some of the challenges that we see into the future going forward. So what are those challenges that we see? There's really two key ones. It's not uncommon to see a lot of projects experiencing capital blowouts between sort of 10 up to 30%, particularly in the last 10 years with COVID and things like that. Some of the common reasons for this, we see a lot of scope growth and also design maturity gaps. There's a lot of optimism at the start of a project. By the time the reality of the project actually kicks in, it can be very, very different to what they started with. Productivity shortfalls, so we all understand the labor shortages, availabilities and challenges in the industry, as well as turnover and things like that. And then there's inflation and supply chain volatility. And again, that's probably more of a COVID-driven thing, but we see it all the time now. Freight costs, steel, concrete prices, the escalations, equipment lead times, things like that becomes very, very challenging. And then there's the permitting, regulatory, and also stakeholder complexity. And it's the start of a project, you often see they work in parallel. So you'll see the project will begin with the permitting also running in parallel. And quite often that permitting can take longer than expected. So by the time it actually gets implemented, there can be quite a big difference between what they started with and what they ended with. So these are some of the pressures and challenges that the industry has to try and keep control of those costs into the future. The second point is really around the increasing complexity of ore bodies. This also can result in lower metal grades. We see that more and more going into the future. The easy stuff's been taken out. Some of the common challenges we see in that, again, higher throughput rates, which means larger equipment is required to achieve essentially the same metal output. So the metal per ton of ore is decreased, so you need to push through more tons of ore just to get the same metal out the other end. What does that mean? It means that your equipment results are bigger, larger equipment's required. That means more costly equipment and also larger energy consumers as well. And there's just the complexity of the ore itself. Often it means that you're getting lower recoveries, lower grades, or it might also mean that you need to grind a lot finer, liberation, things like that. The ore's more challenging to extract, so you have to do things differently. Finer grinding can mean more losses in the fine fractions and just more complexities generally in the treating the ores. So what do we have in terms of at Glencore Technology? Three of our key technologies are on the screen here. I'll talk more about the Jamison cell, but the other ones here are worth noting because these technologies are very good at dealing with complex, high variability ores. The IsaMill itself has been around for about 3 decades, very well established, over 160 installations around the world in just about every commodity. It's a precision German engineered product using our partner Netsch. So again, it has a lot of, I suppose, proven and comfort in terms of the performance that you get out of that unit. Then there's the Jamison cell. Again, very well established. 4 decades it's been running for. We have over 500 installations around the world in just about every commodity. To be honest, we're learning more and more about the capacity of this unit every single year and every commodity and different operation we push it into. One of its unique components is the 200 to 400 micron flotation range, which is a very big differentiator in terms of this of the unit. And then what that leads to is some very, very high performance in terms of what it sets in the industry by having that very broad range of floatability. And then there's the Albion process, which is an oxidative leaching process. Again, very good in terms of dealing with robust or very high variable ores because it's extremely robust in terms of how it can deal with a lot of changing components within that ore. It's safe, it's simple, it's a good alternative to things like BIOX or pressure oxidation, very complex and very sensitive to feed quality coming in. This is a very robust one that can deal with high variable complex ores. Okay, so moving on to the first, I suppose, of my questions there was around the reducing costs. So one of the areas that we've been pushing quite aggressively into is around combining the Jamison cell and IsaMill into what we call the Jamison concentrator. It's a full plant. What that basically means is there's no conventional or other type of flotation devices there. It's purely just Jamison cells, which makes up the entire circuit. By doing this, what it means is we get around 1/4, maybe 1/3 less flotation units. So it's a significant reduction in terms of the size. It also a big reduction in capex. We see around 30% drop in capex. And that's primarily driven by lower steel, concrete, and footprint. But also we have a lot of reduction in energy as well. So around 45% lower energy. There's no blowers used in a Jamison cell. There's no agitators. There's really just pumps. That's the only moving part on a Jamison cell, which also makes it much, much lower in terms of its maintenance requirements and spare parts. As I say, the only moving part on a Jamison cell is the pump. Everything else is basically static and very simple to maintain. Just to the right there, just a couple of examples there. So we had the Jamison concentrator, which has been operating for quite a few years in New Britannia, which is a Hud Bay operation. 4 Jamison cells replaces 11 tank cells, and that's performing extremely well, that circuit. Hermosa, so that's a full concentrator that's currently under construction in the United States, in Arizona. That's 12 Jamison cells, replaces what would have been 40 tank cells. So again, big reductions in terms of footprint and complexity. In the Zorne there, the one at the bottom, that's another one that was 63 tank cells replaced with 19 Jamison cells. And that's actually the picture you can see at the bottom there to show you the contrast between the huge difference in size of the plants. So a question we obviously get quite often is how can you do that? How can you simply reduce it so small and yet get such high performance and have all those savings? I think the savings are obvious. through the reduction in size and units, but how do you still do that and get really, really high performance? And that's probably the key differentiator and the reason why we're so excited about where this is moving the industry. So, as I mentioned before, the particle size range is very important. The 200 to 400 microns, having that in a standard configurated Jamison cell. Wash water systems that enables us to essentially wash out all the gangue without sacrificing any of the recovery, which gives us a higher grade. But by washing out the gangue, it also gives us a huge reduction in mass pull. And that basically means everything going down the circuit is heavily reduced. You're not bringing gangues and clays and things like that into the circuit and oversizing your plant. Finer bubbles that are generated also create significantly higher surface area compared to conventional flotation with big bubbles. And also, one of the key components, and this is the part that a lot of metallurgists in the industry for many, many years, almost a century, struggle with, is the fact that the flotation or the contact happens in around 2 to 4 seconds. So not 40 to 60 minutes, which is what you have in standard configurations of your flotation circuit. So just having a quick look now at what that looks like on these graphs. The bottom one there, that's the standard flotation elephant curve, which I think everyone's familiar with. If you look at the top, this was a survey that was done on a rougher scavenger Jamison cell configuration on a large tier 1 operation. You can see here, most at the bottom graph here, most of the tank cells struggle between sort of anywhere under 15 to 10 microns, around sort of 50 to 70% recovery. If you look at the Jamison cell in this case, that -5 microns, anywhere from sort of 85 to 90% recovery. So massive improvement where a lot of circuits lose all their fines. Same within the +5 to the -38. Again, almost 98 to 99% recovery. What's not really well known in the industry is its ability to float also in the coarse fraction. If you look at this one here, this shows a lot of them around sort of 10 to 30 microns in that sort of 200 to 300 micron range. The Jamison cell you can see here was getting up around in that sort of +300 to -425, was getting around 40% recovery. And what's also very impressive about that is that was a lot of the locked material, which is basically from the QuemScan definition, which is extremely difficult to float on itself, let alone the fact that it's also not liberated as well. So what does that mean going forward in the future? So just a quick overview. So as I mentioned before, the Hermosa one there, that's one that's under construction. There's a couple others here. I obviously can't mention the name, very close to going into execution. But these big concentrators here, big reduction again in the number of cells compared to the conventional, and also big reductions in CapEx and OpEx as well. So thank you very much.
Thank you, Glenn. Good to see the efficiency improvements and the savings as well throughout the globe. Now I would like to see Asker. Now I would like to welcome Asker, who is the industry manager for mining minerals and metals from Endress+Hauser. And ASCO will be showcasing how advanced instrumentation and digital solutions are enabling mining operations to optimize efficiency, enhance safety, and drive sustainability. He'll also explore how the real-world examples of Andrew's houses is helping the mining transition to smarter processing, from automated reagent dosing and flotation to optimized tailings and the solutions that are also reducing downtime in the industry. Over to you, Aska.
Thanks, Clarissa. Hello and welcome, everyone. I'm Askar Tulparov, Industry Manager at Endress+Hauser. It's great to be presented today at the webinar leading by Ostmine and to have you with us for this session on how smart instrumentation and digital solutions are reshaping mining. At Endress+Hauser, we are recognized as a global leader in measurement and automation for the process industries, combining a family-owned heritage with deep technical innovation to help plants run safer, cleaner, and more efficiently. Let's get started. Before we jump to the mine site applications, let me briefly present on that slide what we as Endress+Hauser stand for. As you can see here, we have around 1,200 product families in our portfolio with millions of order code route variants. We have 36 production facilities in 11 countries and on 4 continents. On annual basis, Endress+Hauser delivers almost 3 million sensors and more than 15,000 solutions projects successfully implemented in the last 3 years. 50% of our customers are actively using our digital platforms. More than 3,000 mines worldwide trust us, and more than 5 billion people come into contact every day with products that are manufactured using our measurement technology. Now, if we talk about mining, and in terms of solutions with cloud connectivity, we know that some applications and areas of the mine globally and in Australia as well have been more readily accepted than others. We find the most common applications in environmental monitoring and compliance, asset health and energy monitoring, and then into the supply chain monitoring or monitoring inventory of suppliers or fuels. In a bit more detailed view, here's what the complete architecture system looks like from our perspective, from the data generation through the data transfer and data analysis at the end. On the left bottom side section, we have field devices. In this case, both can be wired and wireless connected via a gateways or edge devices or specific adapters, depending on location and purpose to the asset management cloud or control system. Then asset management data is all available via digital communication outputs, and all of these can be managed either on premise or wirelessly. The ERP integration is going then via OPC UA client to provide the necessary information from that field devices. And in addition to say, we can also rely on and use our own Netillion cloud-based industrial ecosystem as well. Now let's have a look in more detailed view about the field devices and what kind of parameters of the process you can get from that instrument. First one, condition monitoring, enabling predictive maintenance by identifying process conditions that may negatively affect device or asset integrity or process performance. Long-term effects like corrosion, abrasion, buildup, to know what's the optimal time to clean, then mechanical stress, thermal stress, or sensor agent of radiation gamma sources. Secondly, supporting process optimization by identifying process anomalies not critical to the device integrity, but might affect its performance, and monitoring of the device's installation condition to increase the reliability of the measurement point or identify any need for corrective actions. Let's say for that short-term effect, we have a very high-speed Ethernet APL protocol, new value with lots of potential. For example, optimize mixing and blending or pump speed to reduce bubbles. To support you in reaching your goals, Endress+Hauser has implemented its own heartbeat technology into many measurement devices across our product portfolio. Its unique diagnostic, verification, and monitoring functions all aim to support you in your daily striving to increase plant performance. Highest confidence in device performance due to outstanding diagnostic capabilities and international standard compliant development. Efficient operations are supported by timely, clear, and standardized diagnostic messages, providing easy to follow recommendations on the actions needed. Optimize calibration proof test cycles through traceable device verification without process interruption, which is very important. Improved insight on device and process conditions to optimize the process and to keep operations stable. Here's one example of the process like flotation, where you can see what kind of measurement devices potentially could be used and installed with all the digital benefits I described in my previous slides, and based on our years of experience in that applications. Here you can see how many different types of devices are in one place, and there are like flow meters for liquids and air with different measurement principles, like electromagnetic, thermal mass, Coriolis flow meters, then continuous and point level measurement, some critical analytical parameters, then non-contact density meters, and pressure devices. And to summarize my today's speech, here's a short animation video where you can see that flotation process as an example, and generally saying how easy, fast you can get an access to our online tool applicator to do a full engineering sizing on your own level at any time to find the right instrument for your exact application process needs with detailed information like price, drawings, production time, spare part list, and finally with printed out results at the end. So my message to all of you, please feel free to open our website, test it, and use that on your daily basis. So if you have more questions or need support within our online tools, please come back to us and I will be glad to help you. This is all. Thank you very much.
Thank you, Oscar. Great to see how everything is connected through so many devices and technology. Thanks for presenting. Now we'll get started with Jord. So I would like to welcome Sherwin Morgan, Technology Manager for Novacell, and Sam Caldwell, Technology Manager for Dewatering Solutions. In their presentation, they will be covering a lot on the mining industry and the expertise that they both bring to their fields. Sherwin Morgan has over 20 years of experience in the sector, and Sam is a mechanical engineer with 6 years of experience in developing Jord's technology and dewatering solutions. They will be exploring breakthrough technologies that are transforming mineral processing for modern mines, delivering greater efficiency and performance. Over to you, Sherwin, to your presentation. Thank you.
Thanks, Clarissa, for the introduction. So I'll be talking about the Novacell. So before I get started, the first thing to know about the Novacell is it's invented by Professor Graham Jameson, who Glenn spoke about earlier on the Jameson cell. There's some similarities in the technology in that we also have downcomers targeting fine and intermediate particles. But the key difference is there's a specifically designed fluidized bed at the bottom of the device targeting coarse particles and a secondary collection mechanism to boost that coarse particle recovery. So this technology is being commercialized by Jord. Jord is an Australian company, privately owned. It services multiple industries, and the Novacell and the Viper sit in the minerals processing group. Jord has been around for 50 years and has plants in multiple countries. So why is there a big buzz about coarse particle flotation? All right, most of the tier 1 miners and mid-cap miners are starting to include this in their flow sheets. It's because it adds a lot of benefits. So we saw this graph earlier by Glenn, which shows the recovery by size of a mechanical cell. And on the right-hand side, you see that sharp drop away for the coarse particles. If you can recover these coarse particles, it of course allows you to improve your recovery. So there's less coarse particles ending up in your flotation tails. It also allows you to reduce energy. So if you can recover particles at a coarser grind size, there's less energy in the comminution circuit. And then finally, if the particles are coarser, it's far easier to dewater. So it then opens up opportunities to adopt new tailings management solutions. So why is Jord's solution different to what else is out there in terms of coarse particle flotation? Mainly because we've simplified the flow sheet. So because we can recover fine, intermediate, and coarse particles, there's no need to have a upfront deslime circuit. So a lot of the existing technologies struggle on the finer end, so they need to remove these particles and treat them separately in the flow sheet. With the Novacell, we don't have that challenge. We put everything in through one device, and we're allowed to get we're able to get mineral selectivity across all particles. So here's a case study. We've been working closely with Capstone Copper for a few years, and we've tested this technology at one of their mine sites in Chile, called Mantos Blancos in the Antofagasta region. And there were two key criteria that Capstone Copper wanted. Firstly, there was a recovery target, and there was also an enrichment target. So the red line shows the targets, and then the green bar shows the actual results we got through that trial. Capstone's looked at a range of different coarse particle flotation technologies, and their main interest in the NovaCell was the simplified flow sheet, as well as the selectivity it achieves across all size fractions. So finally, if you're interested in this technology, we offer two ways to investigate it. We have a lab unit here in Australia. It's at Core Resources in Brisbane, but also we have a unit in Santiago in Chile at Amen Pro. We also have a pilot unit that comes in two 20-foot shipping containers that can be set up on site to test this technology. I'll now hand over to Sam, who will talk about the Viper.
Thank you very much, Sherwin. And just as Sherwin did at the start of his presentation, I'd also just like to take a moment to note the similarities as well between some of the content that I'm about to go through here in the dewatering space. That's very similar to the theme that Glenn established at the start of this presentation in his slides. And that was really, based around where we looked at how companies are really looking to overcome the issues of capital blowout in terms of headwinds for new projects, and as well as ways to manage all complexity with new innovative processing solutions. So in the vacuum belt filter space itself, Jord is one of the leading suppliers in Australia, where we've been building these systems for over 30 years now. And out of that experience, the Viper technology has been born. So what is the Viper technology? It's our patented innovation that significantly improves the baseline performance of the traditional vacuum belt system itself. The vacuum belt system is a technology that's been around for that whole entire period. We've recently invented these Viper modules shown in the green module sitting on top of the belt filter in this example image. These modules can either be delivered as new equipment, as a fully assembled Viper vacuum belt filter, or it can be retrofit onto existing vacuum belt filters in order to reduce the final moisture content of the cake being discharged and or increase the capacity of the existing belt filter. Now, those two main benefits are a really important point in the dewatering space, as and I guess the reason for that is it unlocks the vacuum belt filter for the more challenging to dewater applications. I guess historically difficult to dewater applications. And the reason that unlocking is important is really shown in this comparison image here. On the left-hand side and the right-hand side, we have two processing plants built in Australia that are operating the same tons per hour of solids, processing the same tons per hour of solids. They're both processing a very similar feed type in a gold tailings material. The plant on the left-hand side is a filter press plant, and Jord also manufactures filter presses as well. We delivered this package a couple of years ago. The left-hand side plant is much larger, as you can see in this comparison. It's more complex, and it's therefore a much greater cost and also more challenging to operate. On the right-hand side, post the invention of Viper, we have a smaller, more simple overall layout that's therefore lower in capital costs and more simple to operate. And it's just to give you a gauge of the order of magnitude of reduction in capital spend and operational expenditure for projects, for the dewatering scope in these projects. Now, we're looking at anything of 50% or more reduction in the capital costs for the dewatering solution for a given application, and at least the 20% reduction in the operational costs of that plant over its life as well. So some pretty significant step change reductions in both CapEx and OpEx costs
with the ability to now select the vacuum belt filter for a given application based on the existence of this Viper technology. In regards to our operating references themselves, we have in the order of 100 Viper modules operating around the globe today. But currently, I just want to highlight this reference here. Currently, the largest duty is the dewatering of fine grind magnetite concentrate, and it's at this plant in Port Hedland, WA. Its duty is in the order of 20 million tonnes per annum of magnetite concentrate. And the real significant point I want to highlight here is 100% of the saleable product from this mine needs to be dewatered by these belt filters, which is the last stage of the flow sheet before it gets conveyed onto a ship and sold to the client. So if we can't meet the performance, the moisture content and tonnage requirements for this project, there is no further piece of processing equipment between this plant and sale to the client. And I like to highlight that just to really reflect the level of confidence that the existing customer base has in this technology today.
Thank you, Sam.
Sorry, go ahead.
Sorry, your time is over. Do you want to just finish up quickly if you want?
Yep, sure. Just take 10 seconds here. In order to scope up your given application, we have bench scale and pilot scale test work capabilities in order to identify and demonstrate the benefit that this technology can bring to your application. Thank you very much.
Thank you, Sam and Sherwin, for the presentation, and good to see the reductions and how both CAPEX and OPEX are being affected. Now, last but not least, I would like to welcome Vishal Patel from Bray Controls. Vishal is the Technical Business Development Manager for Actuation and Controls. Today, he will be talking about mineral processing, extraction, and refining, and how they are considered some of the most challenging applications for the valves in the mining and metals industry. In the session, he will be showcasing how Bray's digital control valve solutions for the mining sector can significantly enhance processing plants' efficiency and reduce unplanned maintenance cost. Over to you, Vishal.
Thank you, Clarissa. Welcome. Good afternoon or good morning, everyone, from wherever you've joined. Okay. So today this year, 2026, happens to be Bray's celebration of its 40th year anniversary in providing, industry-leading innovative solutions for various industrial sectors, mining included. So I'm really pleased to be conducting this, or being part of this webinar this year. We'll be looking at some digital solutions that Bray provides. As many of you might already know, that Bray is a global company. We are across many continents, but in Pacific region, our headquarters are based in Melbourne, Victoria. We do have presence Pacific-wide via our regional offices to cater for any regional requirements in terms of reach and assisting our end users. A quick snapshot on the rotary control valve range that Bray has. In the interest of time, today we'll only be looking at a couple of them, but we have a slurry control butterfly valves, a Series 39 S and L, segmented ball control valves. We'll be looking or touching on Series 19L. We also have high performance butterfly valves, resilience-aided butterfly valves, as well as V-control ball valves. The Series 39 slurry control butterfly valve was initially designed or engineered by Bray Pacific to cater for the alumina industry for the arduous high abrasion, high velocity, and scaling applications. At the back of the success in that industry, the 39 series slurry control valve has made its use case in the mining industry as well. Most recently, we have got what we say generation 2 of the Series 39 slurry control valve, which has an enhanced design with various trim options to cater to medium to extreme wear applications. This particular slurry control valve has a fully lined body with no dead pockets and a hardened material disc, which is a swing through. And we have various options from trim perspective, depending on the severity of the wear and the application, where we would specify either a 4mm CO1 or CO2 trim on the lined versions, or a 4mm, and up to a size of 600 mil. Moving on to the segmented ball control valve options, what we found a common industry feedback on the erosion and the failure points for standard segmented ball control valves is because of its flow direction of the seat upstream, the highest velocity points due to the restriction or the point restriction, which can lead to cavitation erosion and that poor control or non-repeatability. It's concentrated in one section where you can see on the slide the red arrows. We've performed some CFD analysis to unravel in terms of what's actually happening in those segmented valves, and found that the higher velocities were causing cavitation damage, erosion, as well as some eddies were impinging onto the bodies, as well as a downstream flange to cause premature failure, as we can see on some of the images at the bottom. So Bray teamed up with our engineers and came up with a solution which combines a few factors to cater to these erosive service applications. A Bray Series 19L was developed as a drop-in replacement for the standard segmented ball. So what we did is we reversed the flow direction and combined it with some hardened material selection and design enhancement on the drivetrain side, which I'll just show in the next slide. Basically, with the salient features is reverse flow direction. It's also got a pressure balance seat design, which allows a full differential pressure sealing and keeps the actuator sizing down. Engineered materials of construction, where the highest velocity points will be seen at the downstream side of the seat, which is a hardened solid tungsten carbide. It also has a downstream liner to protect from the high velocity or abrasion, which is also solid tungsten carbide, and combined with hardened segment, various options there, tungsten carbide or colmonoy. We have various levels of trim. We also have the option for cladding the body depending on the application. Field repairability was also kept in mind in this one, where the plant doesn't need to remove the whole segment assembly to maintain, but just replace the flange and the retainer assembly and the liner to perform on-field maintenance, just to replace the wear components. We also came up with the bearing seals, the top and bottom, to protect the drivetrain from any ingress, media ingress, which can cause jamming or premature failures. A quick snapshot of our high-performance butterfly control valves. So I won't go into too much details here, but we have various options, can go up to 1500 mil, materials of construction from a seat perspective, as well as body and disc. Resilient seated butterfly valve range. There are also, again, many options, sizes up to 2400 millimeters, various pressure ratings, various seat options in terms of depending on the application, whether it's highly corrosive, chemical, including polyurethane lining for some abrasion resistance. Now, we all talk about, the previous presenters, how efficiencies are required within modules and overall from a mineral processing perspective. And a control valve goes hand in hand with a smart positioner, which is the brain, for example, to be able to tell that control valve to move from one set point to the other as desired by the process requirement. A smart positioner plays a big role. I'll just concentrate on a couple of points for our 6A smart positioner, which has a zero bleed design. So from a sustainability perspective, we are looking at a lot less air consumption in steady state. As from an environment perspective, it's pretty good. And also robust diagnostics, advanced diagnostics, which provides a preventive and predictive maintenance for those control valves to be fully integrated. So if you look at various options in diagnostics side of things, the advanced diagnostics, we can have full stroke testing, multi-step response testing. There are some screenshots that I've shown in terms of what can be extracted if we use the right protocols and measure it up when the control valve was delivered, and build a program as a predictive maintenance program rather than any surprises. Various options are also available from feedback perspective. When we talk about costs of ownership, we always look at the tip of the iceberg, essentially or generally, where equipment costs, engineering costs, etc., are taken into effect. But there is a lot underneath which exacerbates with using either a wrong valve or a different positioner which doesn't have repeated positioning, etc. So how do we cater to that? We, as Bray, we have the valve selection process utilizing our in-house product configurator, which we can size control valves as well as actuation. Our engineers are there at your disposal to perform CFD analysis or applications engineering, as well as we have a valve automation center, which is there to support post supply or for any emergency that may arise. I'd just like to add, Bray is prevalent in many industries and provides many products across many applications. And this slide is a quick snapshot of that. And lastly, a full product portfolio of our overall product range. There is a lot that Bray has in its product portfolio. It's not, I won't be able to do justice to its full portfolio in this short period of time, but yeah, we have all the valves and actuation and controls that are required for a mine to be efficient. So please reach out to our teams.
Thank you, Vishal. I actually started my career in the valves and pipeline industry, so it's always good to see how it keeps developing with good engineering. So let's move on to questions before we wrap up. We received a question today, which it was from James from Always Carbon, and he's asking, what is the water consumption per ton produced? Is that more or less than the traditional plants? Who would like to answer that question? Maybe Glenn or Oscar?
Yeah, I mean,
I think it was more towards what you said.
I think I saw that question pop up. Look, in terms of the Jamison concentrator, in general, look, the water itself is a water balance. So unless you're doing, as Sherwin and others mentioned, unless you're coarsening up the feed, which will make your filtration a lot better, which means you can stop having the need to pump it out to the tailings dam, will obviously have a big impact on your water retention. In terms of the Jamison cell, though, I mean, it operates similar in terms of percent solids to what you would in most other flotation devices. Probably the only benefit you do get was a couple of benefits. One is because there's no moving parts, there's no need to dump it. So in other words, you don't need to get and change stators and rotors and things like that. You can just maintain, you can hold it. So you just run it in recirculation and the entire circuit doesn't need to be dumped. So once it gets dumped and you go out to the tailings dam, you lose it through seepage and evaporation, things like that. The other thing is because the volumetric size of the circuit is so much smaller, it also means your holding, your processed water, things like that is much smaller because you've got less water in terms of your entire circuit is so much smaller. So those are some of the advantages, but in general, the ins and outs are still similar because you're still sending material out to the tailings dam, unless you do a drastic coarsening up of the feed, and then you can do dry stacking and things like that.
Thank you so much, Glenn. So we also received another question, and this one is for Sam Caldwell. It's about the Viper technology. Can you give an example on the potential moisture improvements gained if used in a base metals tailings processing for a P80 or a 108 micron? And also, does the technology impact on the belt scaling? Over to you, Sam.
Yeah, certainly. Thank you very much for your question, Jeb. In regards to the base metal moisture content reductions for your tailings applications, that I would just I'm just kind of going to start by with the kind of standard really response that every application is going to have its own performance mark. If I look at our current application base in our gold and copper tailings applications, we're starting at a mid to high 20% cake moisture basis and moving that down to sub 20. So anywhere from 5 to 10%, 10 percentage points reduction from baseline would be the expectation in those kind of commodities. If I look in the battery elements like lithium, if we look at lithium residue, we're taking that from a baseline of 32% on a standard vacuum belt filter down to, again, that low 20 to sub 20% by weight moisture content target. So they're very large reductions in final cake moisture, and those value reductions differ widely depending on the application you're dealing with. Perhaps you can help me on your second part of the question in terms of belt scaling. Are you referring to scaling from bench testing to pilot to full scale, or are you referring to some kind of water scaling effect during operation itself? I'm not quite sure on that one. Sorry. If you can't clarify here, that's fine. Happy to touch base with you after this on a call. I'm also available there.
James, are you online? Or, well, maybe you guys can touch base after the session to discuss in more detail. I have another question for Aska. You have mentioned that your devices can be connected via the gateways and edge devices. Can the mine site uses their existing gateways and devices, or that doesn't need to be your own?
Yes, correct. Actually, yes, mines can use their existing third-party gateways to be connected to our instruments. So in theory, it's possible. Yeah.
Okay, great. So you can customize depending on what they have and what their needs are.
Yeah.
Good. Thanks, Aska. And I've got one final question for Vishal. Does Bray have a configuration or sizing program that can be shared with clients, and what does that look like?
Thanks for the question. Yes, so we are in the process of coming up with an enhanced version of our product configurator, valve sizing as well as actuator sizing configurator, which will be available for client use in due course. We can confirm the time frame outside of this session, because we'll need to check that with our product engineering team. Currently, it's released internally, but a customer version is in progress. It's current in the final stages of testing, so we should be able to confirm that.
That's great. I'm sure it will be a great solution. And that concludes the webinar for today. So thank you very much for all the presenters and for sharing your expertise. This session will be also available on the Osmine YouTube channel. So if you want to revisit, and for everyone who didn't have a chance to join in live, it will be available and you are going to receive a link. And we have several other webinars coming up, as well as local events throughout Australia. So have a look on what's happening in your region, and we will hope to see you soon. Thank you very much.